Hello everyone, welcome back to my channel Techie Talk with Aditya. Are you preparing for your Java stream training assessment and feeling scared about tricky MCQs from Java keywords, multithreading or exception handling? Then this video is for you. In part 1 of this series, we will focus on important Java keywords and solve real assessment level MCQ that test your basics. These are the exact type of questions you can expect in MCQ-1, and this video is created after analyzing previous year papers. If you are preparing for Java assessment or stream training evaluation, this series is specially designed for you. Before solving the MCQs, let's quickly revise some Java keywords that are very important for the assessment. And the keywords you must know is static, final, finally, finalize, synchronized keyword, extends keyword that we have, implements, private, public, protected, default. You can easily expect at least 4 to 5 questions from these keywords in MCQ-1. So don't ignore them. Now consider the following Java class. Here we have a class called staff and it contains a variable employee ID, and inside the constructor the value is getting incremented. Now the problem statement over here is an organization wants each new employee to get a unique incremented ID automatically whenever a new object is created. So the question is, which modification should be made to achieve this requirement correctly? So the options are, we can declare employee ID as final, we can declare the employee ID as static, we can make the constructor synchronized, or we can use super inside the constructor. The correct answer is option B, declare employee ID as static. And the reason behind this, right now the employee ID is an instance variable. That means that every object gets its own copy of this variable. So every time we create a new staff object, employee ID starts again from 1000, then it increments to 1001, which will result in same ID for every employee. Now why static works over here? Whenever we declare employee ID as static, it becomes a class level variable. This means that only one copy of the employee ID exists. All the objects will share the same value, and every time a new object is created, the value keeps on increasing, and this ensures unique employee IDs. Why other options are wrong? Because if I declare variable as final, value cannot be changed. So increment not possible in this scenario. When I use synchronized keyword, this keyword is used to control the thread access, not ID uniqueness. Super keyword is used to call parent constructor, which is very irrelevant over here. Now let's move to the next MCQ, and this one is from multithreading, a very important area for the Java assessment. In a multithreaded Java application, which keyword is used to restrict a method so that only one thread can execute it at a time? And the options are volatile keyword, transient keyword, synchronized or static keyword. The correct answer over here is option C, synchronized keyword. Synchronized keyword is used to control multiple threads accessing the same method or a block of code. When a method is declared as synchronized, only one thread can enter into the method at a time, and other threads must wait until the current thread finishes the execution, and this helps in maintaining thread safety and prevents data inconsistency. Now let's look at very important MCQ from exceptional handling concept. This is classic trap question and it appears very frequently in Java assessment. Now observe the following Java code that you can see on the screen right now. The name of the class is test finally, and inside this class we have one method check flow. Inside this check flow method there are 3 blocks: try block, catch block and finally block. And from the main method we are just calling this check flow method. So what will be the output of this program? The correct answer for this question is option B. Let's try to understand the execution flow step by step. First, the try block will execute and it will print inside try block. Then return statement is reached inside the try block, but the method will not return immediately. First it will wait for finally block, then the finally block will execute before the return statement and it will print inside finally block. So inside try block is done, then inside finally block, then the return value is sent to main method, and then the main method will print returned from try block, and that's why the final output is inside try block, then inside finally block, and then returned from try. Even if there is return statement inside try or catch block, the finally block always executes, guys. The method returns only after the finally block is completed. And many students think that once return is executed inside try block, the finally block will not run. That is wrong, guys. The finally block doesn't execute only in rare cases like system.exit or JVM crash. Alright, let's move on to the next MCQ. Now on your screen, you can see one Java program. This question is based on static variable, constructor and the ternary operator. So I strongly recommend you to pause this video right now and carefully analyze the code and try to predict the output on your own, because this is exactly the kind of tricky question that appears in the assessment. Now let's try to understand the code step by step. So first we have one static variable, that is count, and that is initialized as 0. Since it is a static variable, the value of count is shared across all the object. Now look at the constructor. So whenever an object is created, the constructor will print the current value of the count. Now comes the most important part, the count plus plus inside the ternary operator. Remember, count plus plus is a post increment. First the condition is checked, then the value of count is increased. So initially count is equals to 0. In the first call, whenever create method is called, the condition is count plus plus is greater than or equals to 0. So now it will check 0 is greater than or equals to 0 or not. So it becomes true, the object is created and count becomes 1 and constructor will print count equals to 1. In the second call, create obj1, the condition is count plus plus is greater than or equals to 1. Now the count plus plus is already 1. So 1 is greater than or equals to 1. It is true, the object is created. After that, count becomes 2 and constructor will print count equals to 2. In the third call, create obj2. Again the condition will be checked, count plus plus is greater than equals to 1. Now the value of this is 2. 2 is greater than equals to 1. Yes, the object is created and count becomes 3. And then the constructor will print count equals to 3. In the fourth call, create obj3. Condition will be checked, count plus plus is greater than equals to 1. So which means that 3 is greater than or equals to 1. Yes, exactly. So object is created and count becomes 4 and constructor will print count equals to 4. So the final output of this code is count equals to 1, count equals to 2, count equals to 3 and count equals to 4. The key takeaways from this, static variables are shared. This question mainly tests your post increment knowledge. Post increment means first use the value, then increase the value. And that's why constructor prints the incremented value, not the old one. Let's move on to the next MCQ. Now on your screen, you can see one Java code. This question is based on interfaces, inheritance and polymorphism concept. So pause the video right now, carefully read the code and try to identify which options are correct. Let's try to understand the code first. So we have two interfaces, interface 1 and interface 2. In interface 1, we have only one abstract method, that is called as calculate. Now look at the second interface. Here I2 is extending I1. That means that the second interface automatically inherits all the methods of the first interface and also declares its own method, that is called as cube. After this, we have one class calculator which implements the first interface, not the second interface. So inside the class, the implementation of the calculate method is important and you can see the implementation in the class calculator. This method is mandatory because it belongs to interface 1. In the same class, there is method called as cube and you can see the logic written over there. This method is optional over here because calculator is not implementing the second interface. Now let's evaluate the options one by one. Option A says that interface 2 inherits the method calculate, which is true. So that means that it automatically inherits all the methods of the first interface, including the calculate method. Now let's try to analyze the option B. Class calculator must implement both calculate and cube, which is false because calculator implements I1 only, not I2. So it is required to implement only calculate, which belongs to the first interface. Let's see option C. Calculator can be referenced using type I1. It is true because calculator implements the interface 1 and this is classic example of interface based polymorphism. I can create the reference of the calculator class and place it in the reference of the interface. Option D says that interface 1 can extend multiple interfaces. which is false in this scenario because yes, in Java interfaces can extend multiple interfaces, but this behavior is not shown in the given code. And in MCQ, we must answer strictly based on the given program, not on general Java feature. So the correct options are option A and option C. Alright, let's see the next MCQ. Now on your screen, you can see one more Java program, and this question is based on thread execution order and join method. So pause the video right now and try to predict the output of this program as well. Let's try to understand the code first. So we have one class that extends the thread, and inside the run method you can say system.out.println work. So worker thread will print work. Now look at the main method. When we call start method, a new thread is created and the run method may start executing anytime. An important point to note over here, we do not control which thread runs first, the main thread or the worker thread. And the next line you can see system.out.println main. So the main thread prints main. Now comes the line t.join. So what does join do? Join method forces the main thread to wait until the worker thread finishes its execution. And finally the last line you can see system.out.println done. So done will be printed only after the worker thread completes. Now let's try to analyze the options. So option A says that it will print work main done. This option is possible because worker thread runs first and it will print work, main thread will run and that will print main. Then join method will come into consideration and ensures that worker finishes the task. And then at last done will be printed at the end. Now let's try to analyze option B, main work done. So it is also possible because main thread will print main first, worker thread will print work, and join method will wait for worker then, and then done will be printed at last. Option C is main done work, which is not possible because join method guarantees that worker thread completes before the done is printed. So work must complete before the done. Option D says that compilation error. There is no syntax error in the code and it will compile successfully. Option A and option B is right answer for this question. Now you should remember this. The start method that we have, execution order is not guaranteed in this case. But when it comes to join, main thread will wait until child thread finishes the task. Now let's take a look at this program. This question is based on multiple catch exception handling. So pause the video and try to predict what will happen at the time of compilation, because this is a very tricky question and can be asked in the assessment very oftenly. So in the try block, you can see throw new IO exception. So clearly an IO exception is being thrown. Now let's take a look at catch block. This is multi-catch block which is introduced in Java 7. And here comes the trick. In multiple catch, the exception type must not be related by inheritance. But here, exception is the parent class and IO exception is a child class of the exception. That means that exception already covers the IO exception. So writing both together is redundant and not allowed. The program will not compile. The compiler will throw a compilation error. So that's why we can say option C, compilation error, is the right answer. Because parent and child exception cannot be combined when it comes to multiple catch. So this was the part 1 of the video where we covered important Java keywords, multi-threading concept and exception handling MCQs that you can expect in the assessment. In part 2, we will solve more advanced and tricky MCQ based question, especially conceptual and scenario based one. If you want a complete PDF of 100 practice MCQs based on today's topic, comment below I want the PDF. I will upload the document to Google Drive and share the access with those who have commented. And make sure you are subscribed to the channel Techie Talk with Aditya so that you don't miss the second part. Thank you for watching this video. I will see you in the next video. Until then, keep learning, keep growing and keep upgrading your Java skills, guys.